Hey there, everybody. Welcome back. For this section, I'm going to take all the crazy stuff that I did in the first section and kind of put it all together into a single problem. We're going to be testing a claim about a proportion for this particular section. The next section will be testing a claim about a mean, and the third one will be about, or fourth section, I guess, will be about a standard deviation. A few of the conditions that must be met. The sample observations are simple random sample. The conditions for the binomial distribution are satisfied, which they all will be, don't worry. Also, the condition n times p and n times q, both of them have to be bigger than or equal to 5. And there's a reason for that, but we don't need to get too deep into that. I want to get more into the actual problem itself. So in this case, we have a drug called Nexium. You can read the first sentence. It's about healing the esophagus. And it says, the manufacturer of Nexium claims that more than 94% of patients taking Nexium are healed within 8 weeks. Then there was a clinical trial. Clinical trials are very important. They're very controlled, usually double-blind. You can look up what that means, double-blind. That means even the nurses administering the medicine don't know if it's the placebo or not. And in that particular clinical trial, 213 of the 224 patients suffering from acid reflux were healed within 8 weeks. So we're going to test the claim, and we have a significance level. Our alpha is 0.01. So remember, the null hypothesis is always equals. And here is our proportion. Our alternate, it says more than, so that's going to be, they're saying that p is bigger than 0.94. So once again, I want to point out that this is, the claim is here. And anytime a claim is made, the responsibility falls on the person making the claim, not the null hypothesis. So we're going to find the value of the test statistic. I'm going to use a sheet that I used in a previous one and see that our test statistic for proportion is right here. You can flip back in your notes and take a look at that. So we have that z is going to be p hat minus p over the square root of p times q over n. And we have that p in this case is 0.94. P hat is the 213 over 223. Q is going to be 1 minus 0.94, which is 0.06. And n in this case is the 224 right there. And we're going to put all that in here. So the 213 over 223 minus 0.94, the square root, 0.94 times 0.06, all over 224. I'm going to show you with my calculator how I'm putting all that in. So this is going to be in my numerator, 213 divided by 223. 224, pardon me, 224. And that is going to be minus 0.94, close, that's my numerator. Denominator, divided by square root, 0.94 times 0.06, divided by 224. Again, be real careful in your calculator. You may be required to use parentheses and things like that to secure that off. And that gives us 0.6865. Now, we have two approaches that we can do with this. We have the classical approach. Here's our Bell distribution. And we have our alpha. By the way, this is a right tail test because it's greater than. So greater than is this way. So our right tail test, our alpha is here. And I know that this is 0.01. They give us our alpha up above, if you take a look right here. And again, it's all right tail, so I'm going to find that critical value. I will use my TI for that. So critical value is going to be inverse norm. And if you remember, it's area to the left, so this is going to be 1 minus 0.01. And there's our critical value. 2.33, we'll say. Now, our test statistic, which we just found, which is up here, is way over here, 0.69, we'll say, rounding that off. And we can clearly see that the test statistic is not in the critical region. So that's how we would compare those. If you look back to the previous set of notes, we can make sense of that. And we'll come to a conclusion here in just a moment. Now, the other approach, the p-value approach, says we have our same alpha. And we take our test statistic. And I'm actually going to find the area here. This is called p-value. And I'm going to find p-value by doing norm CDF. I'm going to start with this number up here, which I start off as the letter A, so I get all the digits, comma. So the A represents the 0.69, comma, 99999. And I did something wrong. Let's try this again. So I'll actually type the number in this time. Normal CDF, 0.6865, comma, 99999. There we go. So that means all of this area, this is the p-value, .2462. So here we would conclude that the test statistic is not in the critical region. And so that's the classical approach. That's the way I grew up doing it. The p-value approach is the newer way that everybody does it now. And here we would say that the p-value, which is about 0.25, is definitely bigger than our alpha, which is 0.01. So either way, you can see that our conclusion is going to be fail to reject the null hypothesis. You can look back at the previous notes. Let's see, I think I have it here. So if the p-value is bigger than, then we're going to fail to reject. Or if we do the other one, if it's not in the critical region, we fail to reject. So both will give us the exact same conclusion each time. So either method doesn't, it doesn't matter which one you use. So we're going to fail to reject the null hypothesis. And so our conclusion is that there is not sufficient evidence to support the claim that Nexium proportion is more than 94%. And yes, you have to write all that out. Let's do another one. Eating together. In a poll, 38% of adults with children under the age of 18 reported that their family ate together 7 nights a week. In a recent poll, 403 out of 1,122 adults with children under the age of 18 reported that their family ate together 7 nights a week. Has the proportion of families with children under the age of 18 who eat together 7 nights a week decreased? So our null hypothesis, our assumption, is that it's still at 38%. They're asking, the claim, has it gone down? Once again, this is the claim. This goes for anything. If someone makes a claim about something, it's their job to satisfy that with evidence and data. Find the value of the test statistic. We're going to use the same one that we did before. Z is p hat minus p over the square root p times q over n. And here we have p is 0.38. Q is going to be 1 minus that. N is 1,122. And Q hat, P hat, pardon me, P hat is 403 out of 1122. So let's pop it in. 403 over 1122 minus 0.38 over the square root 0.38 times 0.62 over 1122. Let's see what we get from that. 403 divided by 1122 minus 0.38 close divided by the square root of 0.38 times 0.62 divided by 1122. Again, be careful with the parentheses on your calculator, that it may not work the same way that mine does. And there we have a negative z value in this case. So I rounded this off, so approximately equal to. So there's my test statistic. Once again, I will do the classical approach. And because this is less than, that means it's going to be left-tailed. And they give us an alpha of 0.05. You can see it right here, 0.05. And I will do inverse norm. And remember, inverse norm is area to the left, so 0.05, nice and easy. Negative 1.64. However, our test statistic is out here at negative 1.44, we'll say. So we can clearly see that the test statistic is not in the critical region. And let's do our p-value approach. Once again, our alpha is going to be the same. I think it's important that you draw these out each time. It really gives you a good kind of perspective and idea of physically what's happening as we do this. And for our test statistic, I'm going to over-exaggerate a little bit, negative 1.44. And we need this area. So I'm going to do norm CDF, and we're going to go from negative 99999 up to negative 1.4368. I'm going to go off that number there. It's a little bit more accurate. And that's going to give me 0.0754. And here we can clearly see the p-value, which is our 0.0754, is clearly larger than our alpha. Which brings us to the conclusion of fail to reject again. The null hypothesis. There is not sufficient evidence to support the claim that the proportion has decreased. I know it seems like a lot of writing, and it is a lot of writing. All right, number 2, our math and science. In 1994, 52% of parents of children in high school felt it was a serious problem that high school students were not being taught enough math and science. A recent survey found that 256 of 800 parents of children in high school felt it was a serious problem. Do parents feel differently today than they did in 1994? And they give us our alpha of 0.05. So our null hypothesis is going to be 0.52. And for this one, it doesn't say increase or decrease or anything, so it's just not equal to. Which means we're going to have a two-tail test, and we're going to split our alpha up. So once again, our test statistic is going to be p hat minus p over the square root of p times q over n. And we have p is 0.52. We have q is 0.48 then. We have p hat, which is 256 over 800. And we have n, which is 800. So here we go. 256 over 800 minus 0.52 over the square root of 0.52 times 0.48 all over 800. So once again, I'm going to use my parentheses, 256 divided by 800 minus 0.52, close, divided by the square root, 0.52 times 0.48 divided by 800. And there's my test statistic. That's huge. So once again, our classical approach. We have our alpha, which is going to be a little bit different this time. Our alpha, because it's two-tail now, it's split up. And we're going to have two critical values. So this area here is 0.025. Again, that's half of the alpha. Keep forgetting to move the paper up, sorry. That means this back here is also going to be 0.025. So our critical values are going to be inverse norm, 0.025. That'll give you the left one, which will be the same as the right one as well. Negative 1.96, making this a positive 1.96. Now, our critical value is going to be exaggerated here. I'm going to go off the page here. Is going to be way over here somewhere. Negative 11.3, we'll say. And you can clearly see. In fact, when we do the p-value for this one, I'm guessing it's basically going to say 0. So here, so negative 99999, comma, negative 11.3228. And it can't even calculate it, so it just says 0. That's how small the p-value is. So I actually did both approaches here. So p-value and it's basically 0. So our conclusion is we're going to reject the null hypothesis. Which means there is sufficient evidence to support the claim that the true proportion has changed. In fact, the large negative means that it's gone down significantly. Oh, there's your first set of hypothesis testing. More to come.